quite a cool little feature that I've just seen in one of the Fujitsu phones, is something that slows down the voice of the person talking. Quite an interesting sort of thing. I didn't understand what it was for. Basically, it's taking the gaps in between people talking and you're slowing down the words that they're actually saying. And the whole idea of this is that it benefits people who might be a bit hard of hearing to sort of make people easier to understand over the phone. It's quite a cool little idea, and I suppose it's quite a simple but interesting thing that they're implementing to try and make our lives easier. So let's have a little look at how this is done. And stop. We're going to have a look now, what does this diagram actually mean? Straight from their website, you can see quite a lot of information about this function. Here's another version of this diagram. So instead of just having the blocks, we're now looking more on the idea of what is actually in these voice blocks. These are actually waves, or sound waves. They say it refers to 3 different types of technology: voice expansion, pause detection, and delay control. Let's have a look at voice expansion. So what would happen if I were to slow my voice down? Now if I was to look at a sound wave, what can I read from how it looks to tell me how it will hear? What's the characteristics of this wave? The way I've drawn this wave is to show the signal strength, or the amplitude, versus time. From this I can see how loud the signal is or how quiet the signal is. The frequency is how quick it takes the wave to oscillate. How quickly it oscillates depends on how high or how low will be the signal. However, nearly all of the sounds that you will ever hear are made up of a mixture of many thousand different frequencies put together. Now, if we were to split our original signal down into individual frequencies to see the individual signals, the job of the voice expansion technology is to be able to slow the voice, yet keeping all these individual signals oscillating at the same frequency. Next, let's have a look at pause detection. What I want us to think about is thresholds. Now this is the wave that would represent in my diagram a word, and this is another wave that would represent the next word, hence here is the space in between the words. But as you can see, there is some noise, background noise. What's important is to find out when the words end and when the words start. But also we must not confuse a word to be noise. Therefore, we must choose an appropriate minimum point. What is key to this entire circuit and all this technology is finding this exact cut-off point. Finally, let's have a quick look at delay control. To describe delay control, I'm going to talk about a buffer. What I want to imagine is that we have a rain cloud and there is water that is falling out of it and it's being collected in this bucket. But we're going to call it a buffer. And then from this buffer, gradually the water will be siphoned off nicely at exactly the level that we want. So when finally the cloud has gone and we still have some water in our buffer, the water will carry on leaving the buffer at the rate we like. This analogy here is explaining how the information of the sound is being held in a memory and then gradually trickled out so that it can become this slower voice. Anyway, so as I say, that's quite a cool little engineering feature now that we are putting in things to try and make our lives easier.